Okay, since we talked about models and projections and how that can be problematic because they are using technologies for future projections like carbon capture and negative emission technologies to define pathways. And the argument was that such technologies do not exist and their feasibility is not clear. It's not even obvious they will scale up, and so on and so forth. The models most used for such scenarios are the integrated assessment models, which are also referred to as climate policy models by some people. So as opposed to Earth system models and climate models, which many of you may be more used to, where we have some first principle equations for equations of motion, Newton's laws of motion, momentum, energy conservation, thermodynamics. And then we have some parameterization of processes of cloud formation and rain, for which we don't necessarily have first principles. So in these integrated assessment models, climate is a simplified box because the focus here is on other boxes like economy, energy system, and land system. And then they get inputs like GDP, population, policies, and there are many other assumptions, as we will see in a minute. And they try to tell you where the economies will head with those interactions and what emissions will do based on the pathways taken to accomplish some of these things, and what are the energy pathways needed if you had certain goals for emissions, and of course what land use would end up becoming based on the agriculture and other land use system, population growth, urbanization, and so on and so forth. So many people debate about the problems with these. For example, GDP and population are the key assumptions driving the models. Integrated assessment models look at a range of future storylines called shared socioeconomic pathways, which we talked about. And secondly, a large economy, this animation keeps going off, but a large economy tends to use more energy met in the cheapest way. Demand for food and fuel affects land use and releases greenhouse gases. So there are many details there, kind of parameters used, assumptions made, because many times these, like land system, there is a first principle equation aspect to it, energy exchange, but there are many not parameters. These changes affect prices as well as the future energy mix, level of deforestation, and whatever the assumptions go in, they're going to determine the future trajectories. And the question is the amount of warming which is then derived from this is how reliable is it? And because these are so-called equations that are cold-hearted, they are not contextual. They should work in every context, whereas the things that are being considered here happen in a context, social context, political context, and the responses are not always known. For example, how Germany is responding to crisis of Russia invading Ukraine, how India and China are responding to these in terms of burning more coal, how China has to deal with droughts, energy shortages by burning more coal, and all these details tend to be very contextual, whereas the equations are not. And secondly, in terms of the goals, researchers can put a limit on CO2 emissions inside the model reflecting policy goal. Often this limit is met by raising carbon prices in the model, driving energy efficiency, and a shift to lower carbon fuels. So it depends on what you are trying to do and what assumptions you make along the way. And emissions are fixed at the start, but prices, GDP, and energy mix change versus the no policy baseline. So often you are trying to compare some sort of a business as usual scenario with multiple what if scenarios. This is very common for industries and militaries, defense organizations. To apply it to climate is kind of a new thing. Nonetheless, what actually comes out also is kind of something one has to keep in mind. For example, these are 2 degree C scenario CO2 emissions from multiple integrated assessment models. So integrated assessment model CO2 emissions in gigaton CO2 and global mean surface temperature relative to pre-industrial across all RCP 2.62C scenarios, which I'm not going to show here. But you can see that the models have peaks at different times and the declines at different times, significantly different sometimes. So you can see the range here, which means even though they are all integrated assessment models, even though they are all trying to give you 2 degree C scenario pathways and the emission trajectories needed to meet those goals, they end up with very, very different rates of drawdown and reaching net zero here. Gigaton CO2 reaching zero can be as early as 2040s or all the way out into 2080s. So these are, and some of them never cross here. You can see AIM, one scenario crosses, the other one doesn't even cross the zero line, and so on. So these are obviously negative emissions here, and that's the big issue as well, that IAMs, integrated assessment models, rely a lot on negative emission technologies, which right now don't exist. Negative emissions play a significant role in typical 1.5 degree scenarios. So these are the positive emissions, and these are BECCS, bioenergy, carbon capture and sequestration, and we mentioned that these are assumptions which are not easily justified in terms of feasibilities or impacts on other things like food security, water security that we mentioned. They also assume things like nature-based climate solutions or natural climate solutions, which add significant negative emissions, but the social and political context for these are hardly obvious, and the pathways would hardly be easy. So there is the total CO2 you would achieve by 2100 with these kind of approaches. So how do we justify relying on non-existent technologies for future? So this was debated in this little article in Nature in 2019. What? Okay. I think it was 2019, sorry. The topic in brief, just read this, the summary. Climate change, including global warming and an increased risk of extreme weather events, is one of the greatest threats facing humanity today. This figure just shows flooding associated with one of the hurricanes. It's a complex issue that involves many social, technological, and physical processes, obviously. To describe the intricate relationships between these processes, scientists have devised computer simulations known as integrated assessment models, which we just looked at. IAMs are used to generate pathways for climate change mitigation that are consistent with global warm temperature targets. So if we assume we want to hit 2 degrees C, these models can give you options with non-existent technologies on how to get there. So they don't worry about the technology will be available, will be ready, will be scalable, and so on. They will just tell you if you had negative emission technologies and if BECCS works, these are the pathways you can take to reach those targets. Some scientists have suggested that IAMs are no longer fit for the purpose and that meeting climate targets will require a radical reinvention of industrial society that the models are not equipped to address. So this is what we also kind of talked about in the last podcast about model scenarios and politics of prevarication and technological promises which are used to make those promises. But others have argued that IAMs are an indispensable tool for exploring how to reach climate targets and are a key building block in understanding feasibility of these targets. So legitimate debate, but you can see the words used can be quite harsh. The one who argues that this is a wrong tool says, behind the veneer of objectivity, the use of these Leviathan computer models has professionalized the analysis of climate change mitigation, climate change mitigation by substituting messy and contextual politics with non-contextual mathematical formalism. So IAMs are very technocratic. Within these professional boundaries, IAMs synthesize simple climate models with a belief in how finance works and technologies change, and buttressed by an economic interpretation of human behavior. Obviously, quite an indictment. But the other side says by providing crucial knowledge about the driving forces of climate change and the magnitude of transformations needed to reverse these forces, IAMs play a central part in the climate. Sorry, I'm not good at editing these things. Something went wrong with my computer. So let me start here again. The argument against IAMs by this debater is that they assume small changes around equilibrium and look at deviations from the equilibrium in terms of economics and human behavior and so on, and then they interpret human behavior, economic interpretation of human behavior is involved. But the supporters of the IAMs would say that by providing crucial knowledge about the driving forces of climate change and the magnitude of transformations needed to reverse these forces, so not just small magnitudes but as large as needed, IAMs play a central part in the climate debate. Originally, IAMs were used to generate scenarios that described how emissions would evolve in the future on the basis of plausible, internally consistent economic and technology developments. The idea is that such approaches are what-if scenario approaches also used by militaries, by industries and so on. So there is nothing wrong in planning these, and then you have to justify the use of technologies that don't exist yet. The main contribution of these scenarios was the warming that existing trends would lead to dangerous global warming in the 21st century. So the idea of what is dangerous climate change also has been debated, but nonetheless the challenge of evaluating feasibility is that the pathways are constrained not only by economic costs and technical complexity, but also by socio-political acceptability. This applies not only to pathways generated by IAMs through mathematical algorithms, but also to climate-safe futures imagined through visions of radical reinventions of society. So the idea is that IAMs are not just giving you incremental changes in the decarbonization on the way to global warming targets, that they can actually be also applicable to climate safe futures which are imagined with radical reinventions of society. The main thing also as a cautionary note would be that when people use future projections of warming and the related dynamic thermodynamic changes to locally produce information on heat waves in the latter part of the century, droughts, drought risks, health, all kinds of extrapolations are made, especially at local scale. Then of course there is a challenge of knowing how skillful the projections are at a local scale, because these models are global. They're good at taking anthropogenic forcing and producing global level warming, sea level rise, etc., and temperatures are better done than precipitation. So the main caveat to remember, if you're not an expert in this and don't want to bother with this, is that the projections uncertainties are dominated by the model uncertainties in the first decade or two. Scenarios don't matter that much in the beginning, but when you go beyond 2050 or so, uncertainties from the scenarios themselves begin to affect the projections. So if you are doing things like drought risk and you don't know that, uncertainties from the scenarios can produce all kinds of risk maps, then you may be misinterpreting or at least underestimating the uncertainty in that sense. So the contextual real life social political context of how things happen in the real life is not necessarily captured in its full glory by the IAMs, which are very technocratic, as we said before. So one has to then see what the uncertainties are, what governments do with those kinds of projections. If the question is still the same as the last podcast, if politicians can use these scenarios to say we will have negative emission technologies and BECS will work and we can keep burning fossil fuels at this rate, then we are already in that range where mitigation is way behind in terms of the drawdown that needs to happen to meet any of these targets. So delaying mitigation, relying on these unproven technologies as saviors of the future is an issue. And the question is whether IAMs just play into this and become tools of convenience for politics of prevarication. That's still the question. Okay.